The modern lithium-ion cell, the workhorse of the past 30 years, has become a roadblock for high-voltage applications like EVs and grid storage. The cylindrical cell was originally designed for laptops and later adopted by early EV makers. They waste space between cells, space that could store more charged material. Each metal casing adds weight, reducing energy density and range. The ideal battery would use minimal packaging, which isn't possible with traditional cells. Manufacturers also tried prismatic cells, larger rectangular versions that cram in more material, pushing safety boundaries. They pack more efficiently, but add heavy metal casings that lower energy density. Finally, prismatic cells contain a much higher amount of flammable electrolyte, meaning that any short circuit in the cell will have much higher explosive energy. 24M's breakthrough ETOP eliminates cells entirely in high-voltage systems. ETOP, electrode to pack, uses only electrode pairs and separator sealed in thin films. These sealed electrodes are packed directly into the battery, making ETOP the closest version of an ideal battery, just active material in a wrapper. Its sealed electrodes fit any shape and need no metal cans, freeing space and boosting energy density. See the power of this uniquely flexible shape, the elegant space efficiency and energy density of a 24M polygonal cell in an eVTOL or drone wing. Far superior to a bulky prismatic cell. Compared to conventional packs, ETOP improves packaging efficiency by 35% and reduces costs by 40%. Meanwhile, traditional cells have grown more problematic. As manufacturers push for higher energy density, safety issues arise. Cells always have a slightly larger area for the negative electrodes to prevent lithium dendrites. This safety overlap, however, reduces capacity. To squeeze in more energy, manufacturers shrink the overlap, increasing the risk of dendrites, shorts, and thermal runaway. ETOP's large electrodes can easily maintain a safe overlap as it forms a much smaller portion of the total area. ETOP has none of these drawbacks: no individual metal cans, safe electrode overlap, and no large shared pool of electrolyte. Each pair is sealed in its own film. ETOP makes it much easier to build compact, high-voltage batteries. All you have to do is flip the unit cells as you stack them in the case. For comparison, a typical CAN cell only reaches 4.6 volts, as it's really just one long, rolled-up electrode. If you took that same CAN and stacked 11 24M unit cells inside, flipping every other one, you could turn it into a 48-volt battery by wiring them in series. The ability to just flip a unit cell makes it easy to mix series and parallel connections, giving designers flexibility to build compact and efficient 400 to 800 volt batteries, perfect for electric vehicles and energy storage. ETOP eliminates cell manufacturing entirely, offering a simpler path for EVs and ESS OEMs. OEMs can now integrate an ETOP manufacturing module directly into their pack assembly line. To make each sealed electrode, the manufacturer first cuts to size a prefabricated anode and cathode, with the desired active material such as graphite for the anode and LFP for the cathode. Note that both electrodes have a plastic film backing that will be used to seal the electrodes together in a kind of battery sandwich. After being cut to the right size, each electrode is sprayed with electrolyte. A separator is rolled onto the anode. The cathode, which has also been sprayed with electrolyte, is placed on top, forming the electrode sandwich. The plastic films are sealed together, locking the separator in place. All these steps, from cutting to sealing, happen in a single machine. The sealed electrodes are then inserted directly into the pack. ETOP is compatible with 24M's Impervio separator for added safety and 24M's Eternalite electrolyte for fast charging and down to -40-degree temperature performance. ETOP eliminates traditional cells and their heavy cans, unsafe electrodes, and explosive shared pools of electrolyte, delivering a revolutionary platform optimized for high-voltage applications with the highest pack energy density, flexible shapes to fit any structure, and ultra-safe construction. This is all possible now and only from 24M. It's simply a better design, a better battery, a better energy future.